Dithering transparency, or screen door transparency as it's also known, is a technique that's been used in several games, such as Super Mario Odyssey, as an alternative to traditional alpha-blended transparency. We can recreate this effect in Unity using shader graph and just a handful of nodes. The source code for this project is available on GitHub. The link is in the description. To use shader graph, you need to be using a scriptable render pipeline. I've created a brand new project using the universal render pipeline template. If you haven't installed URP, you can go to the package manager and select universal RP from the list of packages. Make sure all packages are selected so that the universal RP option appears. First, we'll create a new shader graph, so go to Create, Shader, and we'll select a new PBR graph. It stands for Physically Based Rendering, and it means that our model will be affected by natural looking lighting. I've named mine Dither Transparency. Then, double-click the new graph to open up the shader graph editor. For our shader, we are going to need a few properties. These are like variables, which we can expose to our material inspector, so different materials using this shader can behave differently. The first one is an albedo texture, of type Texture2D, which will control the base color of the object. For each property, the exposed checkbox controls whether this property appears in the material inspector, and we can enter a name in the reference field, which we can use to control this property inside C# scripts. Next up is an albedo color, of type color, which will be used to multiply the albedo texture. This allows us to tint the object. By default, we'll give it a white color so that the albedo texture is left untinted. Then, we'll add a vector 1, that's just a scalar value, called opacity. This value will let us change the entire object's level of transparency. A value of 0 gives a fully transparent object, while a value of 1 will result in an opaque object. Well, depending on the transparency value of the albedo texture and color anyway. Strictly speaking, this property isn't necessary. We could just modify the alpha or transparency channel of albedo color instead, but I prefer to make this a separate property so it's a bit clearer what we're doing. We'll add another vector 1 that lets us control the dither size. This will be the size of the dithering pattern, so a larger value means the individual pixels, inverted comma or pixels, of the dithering pattern get bigger too. And finally, we'll add an emission color. This also isn't necessary, but I want to make the eyes on our model glow. We'll set its mode to HDR so that we can use the bright luminance values supported by high dynamic range. You could easily add more properties for a normal map, metallics, smoothness, and so on if you have a model that you want to use those things on. In fact, we're going to add the emission to our shader first because it's the easiest step. There's more than one way to add a property. We can drag the name of the property onto the graph, or we can right-click, select Create Node, and type in the name of the property into the search bar. If we drag out a connection from the tiny circle, or pin, of the property, we can connect it to the corresponding input pin on the PBR master node. Next, we're going to deal with the albedo and alpha pins on PBR master. We can't just drag the albedo texture property onto the graph and connect it to the albedo pin straight away. We need to use a sample Texture2D node. This takes in a source texture, which in our case is the albedo texture property, and a UV coordinate. We'll leave that as the default UV0. We need to multiply this texture sample by the albedo color property to get our desired albedo value, which we can then connect to the albedo pin on PBR master. We also need to get the alpha channel, alpha means transparency, from this, so we'll use a split node to separate that part of the color away from the red, blue, and green channels, and we'll pass that into another multiply node together with the opacity property we defined before. You can use the tiny arrow here to hide the unused color channels on the split node. Then we can connect that to the alpha channel of PBR master. It's good practice to keep your graph organized by grouping nodes together. Left click and drag over this set of nodes, right click and group selection, then give it a descriptive title. Now for the dithering. Unity includes the dither node right out of the box. The in parameter controls the brightness of the dither pattern. It's totally black by default, but if we set this to a higher value like 1, the brightest pixels are white. Lower values get a bit dimmer. We'll just keep this at 1. If we connect this to the alpha clip threshold field on PBR master, we'll already see results when we tweak the opacity. What's happening here is that any pixel whose alpha value is lower than that of the dithering pattern is getting clipped. They're not rendered. Finally, we'll factor in the dither size. Since the dither pattern is generated in screen space, we use a screen position node and then divide it by our dither size property. That means as the dither size increases, the dithering texture is scaled up. As before, it's good practice to group those nodes together and give them a descriptive title. Let's return to the scene view. The model I'm using is the robot sphere, available on the asset store, link in the description. Inside the project view, you'll see I've upgraded all the materials that model uses. You can use the shader graph that we just created by using the shader dropdown and selecting shader graphs, dither transparency. We can then provide the albedo texture and all the other properties, which I've already done. We can play around with these values and the scene view will update in real time. You can already see the dithering clearly when we've reduced the opacity of the material. Just to show you what the emission looks like, we can set a high intensity green colour and the model starts to glow very brightly. This happens because the default scene has a bloom post-processing effect applied. With high intensity emission and a low opacity, you can make the object look a bit like a hologram. That's it for this video. If you've learned something today, perhaps you'll consider subscribing or checking out my Patreon. Thanks for watching.